The third part of chapter 2. Today we are going to talk about density. So density compares the mass of an object to its volume, and the way that we are going to calculate it is the mass of the substance divided by the volume. So we have density equals mass over volume, or our equation that we are going to use is D equals M over V. Density is mass over volume. Substances that have a really high density, that means that the particles are really closely packed together, and dense substances that have a low density have particles then that are farther apart. In the metric system, we have densities of solids, liquids, and gases, and we will express them with different units. The density of the solids are usually given in grams per centimeter cubed, and the density of the liquids are usually given in grams per milliliter. These are the same thing though. The way that we calculate them is exactly the same, and they mean the same thing. Because if you'll remember from our last slide, 1 milliliter is the same as 1 centimeter cubed. Okay, so this grams per centimeter cubed and grams per milliliter, they mean the same thing. We just calculate them differently because it's easier for us to calculate solids in centimeters cubed and and liquids in milliliters. So we give them different units. They mean the same thing though. Our density of gases, on the other hand, are given at grams per liter. And this is because particles in a gas are really, really far apart. We are not really going to do anything with the densities of gases, though. We're going to stick with solids and liquids for this class. So if you'll look, here's some common substances that we have the density of. So like ice is 0.92 grams per milliliter. Lead, which we know is really, really heavy, right, is 11.3 grams per milliliter. And then we have the density of some liquids. We have gasoline, we have ethanol, and what I want to point out to you is that substances that have a lower density than water will float. So if you'll look, ice, right, we know ice floats in water, and ice here is 0.92 grams per milliliters. It has a smaller density than water, which is why ice will float. Same thing like with oil. We know oil sits in a layer above water. Oil has a lower density in water, which is why it floats on the top of water. Substances that have a higher density than water will sink. Like if you put, iron in water. Iron has a much higher density than water, so if you stuck iron in water, it will sink. That's another thing. Like if you put gold in water, right? You had a bunch of gold lying around and you put some gold in water, it will sink. So things that have a lower density will float. Substances that have a higher density than water will sink. And I do want you to remember that the density of water is 1.00 grams per milliliter. I do want you to know that. Any of these other ones, I will always give you the density. Please do not go around memorizing the densities of these substances. But if you need them, I will give them to you. But I do want you to know water has 1 gram per milliliter, and anything that has a lower density than water will float, and anything that has a higher density than water will sink. So let's get some practice calculating density. A 0.258 gram sample of a high-density lipoprotein has a volume of 0.215 centimeter cubed. What is the density? Okay, so what I want you to always do first when solving these kinds of problems is write down all of your variables. We know that we're solving for density. So we have density is equal to mass over volume. So we need to outline all of those variables. So we go density, mass, volume, and figure out what do we know. Okay, so in the problem, we see that we have a mass of 0.258 grams. So we put that for M. And we have a volume of 0.215 centimeter cubed, so we put that for V. And we're going to put a question mark up here for density because we don't know what the density is. Okay, so in this way, we've figured out, okay, here's all of our variables that we're going to use. Here's what I know, and here's what I'm trying to find. Please note, you must always have the mass in grams. If your mass is not in grams, like if it's in kilograms or milligrams, you will need to use the conversions we talked about last time to convert it into grams before you can calculate the density. Similarly, the volume always has to be in centimeters cubed or milliliters. Either one is fine, but it has to be one of those two. If it's in liters, you're going to need to convert it into centimeters cubed or convert it into milliliters so that you can use it in this problem. Okay, so our next step is to write out the density equation. Density equals mass over volume, or like I said, just write it out as D equals M over V. So then, once you have all of that in there, you can go ahead and solve. So density equals mass over volume. So density equals 0.258 grams over 2.15, or you can write it like this. Right, either way is fine. And then you'll divide them up to get your answer. 0.258 over 0.215 gives us 1.2 grams per centimeter cubed. And if you can always box in your answers, that would be great so that I can find them on your homework. If I can't find your answer on your homework, my guess is that you either didn't do it or you're not proud of your answer, which means you probably did it wrong. So I'm not going to look that hard to find your answer. So please make sure you're always circling or boxing your answers so I can find them. Also, remember, you must always include the unit, okay? For density, it's always either going to be grams per centimeter cubed or grams per milliliter. And the way we can figure it out, right? This has grams, centimeter cubed. So when we divide them, this is grams per centimeter cubed. That ends up being our unit here. Okay. So that's a really, really simple density problem where you're given grams, you're given centimeters cubed, you can just divide them up and move on. A lot of times we don't have regularly shaped items. We have weirdly shaped items. So it's hard to figure out their volume because we can't just do, like, it's not like a cube, right? We can't just do length times width times height and figure out the volume. So often we will use this method called displacement. And so if you'll look down in the bottom two pictures with the graduated cylinders, the way that we will do this is we will measure the volume of the graduated cylinder before we put the metal in. So it says here that this is 35.5 milliliters, just the liquid by itself. And then we're going to take this bar of zinc and we are going to drop it into the graduated cylinder. And after that, we can figure out, okay, now the volume is at 45.0 milliliters, right? Because the volume will go up since you added the zinc. So we can figure out the volume of the zinc by subtracting these two numbers, right? We can take our 45.0 minus 35.5, and we'll get that this is 9.5 milliliters, right? That is the volume of our zinc, or 9.5 centimeters cubed. Again, remember that those are the same thing. So when we have a solid and we do it by displacement, you're always going to have two volumes like this, 45.0 and 35.5, and you'll just subtract them to figure out the volume of your zinc, or the volume of whatever metal you have. Okay, so that's going to be the volume. The mass will be just the same. We can weigh that object. So like here in the bottom left, we have the mass of our zinc. Again, the only thing that's different is that the volume of this zinc was a little bit tricky to get, so we used the volume of displacement rather than trying to use a ruler and figure out the volume of a cylinder and all that good stuff. So let's try an example with this. This says a lead weight used in the belt of a scuba diver has a mass of 226 grams. When the weight is carefully placed in a large graduated cylinder containing 200.0 centimeters cubed of water, the water level rises to 220.0 centimeters cubed. What is the density of the lead weight? Okay, so again, we're working with density, so we know density equals mass over volume. So the first thing that we're always going to do is going to write dmv, and we're going to try and figure out what those are. Again, we're solving for density, so we're going to put a question mark there. We want to know what the density is. The mass was given in the problem. It has a mass of 226 grams. So we'll put that there. And then we'll notice that we have two volumes. Anytime you have two volumes, that's telling you that you're going to solve it from displacement, right? And the words tell you that as well. I just know that sometimes a lot of us get tripped up with these word problems like that. So whenever you see two different volumes, that likely means that we are going to solve for the volume by displacement. So we will subtract them. So we'll do the volume after the metal is added minus the volume of the metal before the metal is added, and then we'll subtract them to get the volume of the metal. And that is our volume that goes here. Make sure you're not writing either one of these numbers for that volume, because this needs to be the volume of the metal by itself. And we'll always calculate that via subtraction. Okay, so now we have density, we have mass. We're solving for density, but we have mass and we have volume. And so we can go ahead and calculate it up. Again, density equals mass over volume. So D equals M over V. So we can write this as 226 grams over 20.0 centimeters cubed. So we can divide those up and we will get our answer, 11.3 grams per centimeters cubed. And again, go ahead and circle that or put a box around it so that you can, so that I can find your answer, and so that you can too. Always make sure though, keep that unit there. Okay, based on this, go ahead and try out problems 25 through 31 on your Chapter 2 lecture worksheet. This is going to give you some practice doing these calculations. Some of them, like I said, are not in the right units. Like if you look at number 26, it's telling you that the volume is 0.100 liters. But I told you that we need to make sure that our volume is always in milliliters. So we'll need to convert that liters into milliliters. And we know our conversions, 1 liter is equal to 1,000 milliliters. So we can make a quick train track here. Now remember, liters has to cancel liters down to the right. So we'll put this portion, that 1 liter, is going to go on the bottom, and the 1,000 milliliters will go on the top. Liters cancels liters, so we have 0.100 times 1,000 divided by 1, which gets us that this is 100 milliliters. So after you get things in the right units, then you can go ahead and solve your density problem. So if you have pounds, you'll need to convert it to grams. If you have kilograms, you'll need to convert it to grams. Liters, you'll have to convert to milliliters, and so on. So make sure that you are doing these conversions before you solve for density. And after you finish problems 25 to 31, go back and check your work against the answer key for Chapter 2. Don't just assume you've done it right. Make sure that you are doing it right. And if you come up with problems, please send me a question. You can actually take a picture of your work and send it to me on Remind, and then I can give you feedback and tell you what you've done wrong. But the first thing I would do is do the Chapter 2 lecture worksheet, check the answers against the answer key, and then if you still have questions from there, go ahead and shoot me a question on Remind. So pause here and then come back so that we can continue on with the lecture. Okay, sometimes we will actually need to rearrange this density equation. We're not always just going to be solving for density. Sometimes we'll need to solve for mass, or we'll need to solve for volume. So here's one. Greg has a blood volume of 5.9 quarts. If the density of blood is 1.06 grams per milliliter, what is the mass in grams of Greg's blood? Okay, so now we're going to go through and we're going to outline our variables just like we did before. So we have density equals mass over volume. So we'll do D, M, V. But now we're not solving for D. We actually have our density, 1.06 grams per milliliter. And it says the actual question is, what is the mass in grams? So that is what we're trying to solve for. So we'll put a question mark on M. And then the volume, it has 5.9 quarts. But we can't use it as quarts, right? We're going to need to convert it to milliliters before we can go ahead and do this problem. So we know a conversion from that table that will allow us to get from quarts to milliliters. So we have 1 quart is equal to 946.4 milliliters. You do not need to have this memorized, okay? I will always give you these conversions that are going from English to metric like this, the 1 quart to milliliters. You are only required to know the conversions that have prefixes like kilo or milli, things like that. You do not need to know the conversion from quarts to milliliters. Okay, but I do expect you, if I give you the conversions, right, if I give you these equalities like this, you need to be able to actually use it to convert things. Okay, so now we can go about converting our 5.9 quarts to milliliters. So we'll make our train track. Oh, that all flew in at the wrong time. There's the answer. So we have our 5.9 quarts up in the top left, and we know quarts has to cancel quarts down and to the right. So if we have quarts here, we'll have to have quarts on the bottom. And remember, we can write two different conversion factors for this equality. We can put 1 quart per 946.4 milliliters, or 946.4 milliliters per 1 quart. All right, we can always write 2. We need to use the one that puts quarts on the bottom so that our units cancel out. So that's going to be this one, right, because quarts are on the bottom. So 1 quart will go on the bottom, 946.4 milliliters will go on the top, and then we double check that quarts cancels quarts, and we're left with milliliters on the top, which is what we need in order to do this work, okay, in order to do this density calculation. So if we multiply the numbers on the top, right, if we punch in 5.9 times 946.4 divided by 1, we are going to get this number here. And again, I always keep 2 decimal points just until the end. Okay, so now though, we have density and we have volume, so we need to rearrange our equation to solve for mass. Because right now, when we have density equals mass over volume, mass is not by itself, and we need it to be in order to solve our problem. So the way that we do this is we are going to multiply volume by both sides. And when we multiply volume on both sides, that means our volumes cancel out. Okay, so then we're left with volume times density equals mass, which is now by itself on that side. So volume times density equals m, and we can actually just flip these around because I like having whatever I'm solving for on the left. So I just flipped it. I literally just wrote it backwards, flipped the left and the right. So mass equals volume times density. So mass equals volume times density. We have, oh, I've written these reversed, but you get this. This is the density. This is the volume, okay? And so we can multiply those out, and we get our mass here. Again, remember to put our units. Our units are grams. Okay, so that would be an example of how we would go ahead and solve for mass. Okay, so now let's do another one just so we get some more practice. In a laboratory experiment, a student measures out 0.153 kilograms of ethanol, which has a known density of 0.8 grams per milliliters. What volume of ethanol in milliliters is the student using? Okay, so again, we know that we're solving a density equation, so we have density equals mass over volume. And again, what we're always going to start with is dmv. So our density, they gave us in the problem, 0.78 grams per milliliter, so we'll write that there. Our mass, they gave us in the problem, 0.153 kilograms, so we'll write that there. But we're going to need to convert it to grams before we can actually do our problem. And then volume, right? That is our question. What is the volume of ethanol? So that is what we're trying to find. So our first step is to take our kilograms and convert it into grams. We know that there is 1 kilogram is equal to 1,000 grams. That one you need to have memorized. So we can write two different equalities. We have 1 kilogram, or sorry, two different conversion factors. 1 kilogram per 1,000 grams, or 1,000 grams per 1 kilogram. Okay, so we're starting with kilograms, so 0.153, so again, this came in the wrong order, sorry, but 0.153 kilograms is going to go in the top left, and we need to cancel kilograms down and to the right. So if I have kilograms here, then I need to have kilograms on the bottom. So we're going to use this one that has kilograms on the bottom. So 1 kilogram will go on the bottom, and 1,000 grams will go on the top. Kilograms cancels kilograms, and we're left with grams, which is what we were trying to find. So then we can go ahead, 0.153 times 1,000 divided by 1, and that's going to give us 153 grams. So now we've got everything in the right units. We have density in grams per milliliters, we have mass in grams, and we can go ahead and rearrange our equation. So we know density equals mass over volume, and we're trying to solve for volume, which is on the bottom. Volume's the trickiest one to solve for, okay, because it's on the bottom. Our first step is going to be just like we did last time. We're going to multiply volume by both sides, and then that will allow us to cancel out those volumes and leave mass by itself. So mass equals volume times density. And so if we were trying to solve for mass, we would stop there because we've gotten mass by itself. But we aren't trying to solve for mass, we are trying to solve for volume. But now volume is stuck next to density. So we successfully got it out of the denominator, but now we need to get it by itself. So we're going to divide by density on both sides. Okay, so we're going to divide by density and divide by density. That causes these densities to get canceled out on this side, and then we have volume by itself. So volume equals mass over density. Then you can go ahead and plug in your values and solve. So we have our mass, which is 153 grams, divided by our density, which is 0.78 grams per milliliter. Once you divide those, you'll get your answer, 196.15 milliliters. Okay. The trickiest part for a lot of people in this particular section is this rearranging the density equation. Okay, so your one option would be you could memorize all three of these equations if you really wanted to, right? You have density equals mass over volume, mass equals volume times density, and you have volume equals mass over density. So if you really got in a pinch, you could memorize those. But it is better to do this, this process of rearranging the equations. I just know there are quite a few of us in the class that math isn't our strong suit. But if you keep practicing, I think you'll find that you get better at it. But then, like I said, plug it in and solve. So now you'll work on this last page of the Chapter 2 lecture worksheet. That is problems 32 to 38. That's where you're going to get some work on rearranging the problems and working through it. Make sure, again, do the problems and then check your work against the lecture worksheet key. If you're really struggling, use the answer key to help you work through how to solve the problems. For all of them, I've written out my work so I can show you how I've solved the problem. So if you're stuck and you just need some help, check answer key. See if that helps you. And again, if you ever get stuck, please feel free to reach out to me or to reach out to our SI, and we will help you out.